ever looked at a spark or a voltage of electricity and wondered, I wonder how that works? Well, let me tell you about the photoelectric effect. Now, the photoelectric effect is when electrically charged particles are released from or within a material that has been struck by electromagnetic radiation. Now, the electromagnetic radiation can be the infrared, visible light, ultraviolet, X-rays, and gamma rays. The radio waves and the microwaves are not included in the photoelectric effect. Now, the material that's going to be struck is going to be a metal. Now, the metal sits in the middle of the periodic table, and the middle of the periodic table has their valence shells only half full. And because all these metals are half full in their valence shells, this means that their electrons are able to jump from atom to atom very easily. They're more willing to either give up or gain electrons, whichever suits their outer shell. Now, because they're able to jump so fast, this is when we see the electrons jumping back and forth. That's when we see the light. That's when we see the voltage of electricity. The best way this can be shown is in a phototube. Now, a phototube is a cylindrical vacuum, and this cylindrical vacuum has two metal plates on each end. One is a cathode, and one is an anode. Now, these cathodes and anodes are oppositely charged, so whenever the electromagnetic radiation hits the end, it's going to bounce off the other end, and that's when you see the voltage of electricity in the phototube. So, the reason this is so important is because the photoelectric effect was later added onto by Albert Einstein in 1905. In 1905, Albert Einstein introduced what's called duality. Now, the duality of electron means it acts as both a wave and a particle, and that the light coming from whichever source also has duality. It acts as both a wave and a particle. So because of this has changed the way of science, physics, chemistry, biology, everything that we know. And this has created our modern day curriculum. And that's why this photoelectric effect is so important, because it's used in our current day objects. One of the most famous being the box television. The box television uses a cathode ray, which the cathode ray is a bunch of electrons coming from the photoelectric effect. That's why it's so important, and that's why you now know about the photoelectric effect.